Well, what I want to do next is move into the use of geography and quantitative geography and SQL. Now, this is going to be based on my textbook that I wrote called An Introduction to Statistical Problem Solving in Geography. I teach a course in quantitative geography and spatial statistics. This is the textbook that's used. It's used in universities all around the world. So you can always pick up a copy of that as well. But we present some of the data and some of the processes in spatial statistics and quantitative geography in some simplified examples, and then we move into real world examples, sort of like how I do this course now. So one of the things we do is we are looking at spatial analysis and quantitative geography within the context of statistics and geography, and this is used a lot in GIS. Now, many of these classical analysis tasks are difficult to accomplish with the GIS, and once again, the GIS field has responded by creating wizards that step people through, or special tools. Again, if we think back to spatial is not special, if you can look at a formula and recreate that in SQL, you can develop your own. So with spatial SQL, they can become self-contained autonomous queries. So before we get too deep into doing some things, let me just show you. Here's some of the data. So these are 7 points that we created, A through G, and they have coordinates associated with them, and they also have some frequencies associated with them that we'll use later. So the first thing I'm going to do is actually copy all this and bring this back into the DB Manager. And I've got just a blank canvas of a QGIS project, so there's nothing in it right now. And we'll step through what these SQL statements actually do. So the first thing we're going to do is create a table, and that table is going to be called points, and it's going to have a graphic ID or a GID. It's a serial value, meaning as I add new points, it'll auto increment the point number. The name of the point, A through G. The frequency value, so I've got values for what each of these data represent. And then the geometry itself, which is a point data type. So when I create this, when I issue this SQL command, it's going to create an empty table. From there, I'm going to be performing the insert statement. Remember, we looked at that earlier as well. So I'm inserting into that points table the name of the point, the frequency value, and the geometry. So the name of the first point, the value is A, the frequency is 5, and the point or the geometry is making a point based upon this coordinate, and I'm going to give it a planar SRID just so it could just kind of show up in space, and then I'm going to end that with the parenthesis, and that will create the first record. Then I do another insert statement, and then another insert statement, and so on. So we do that for each of them. That's done. So if we come in here and we reconnect and come in, we can see that I now have a table called points, and we can select all this and say select star from points. We'll execute that, and these are our points. And I can put the points actually in QGIS, and then you can see the 7 points that we have, and this is the data about those points. So let's look at our first question, central feature. This is a GIS task that often wants to find out what is the centermost feature in a data set. In other words, with all of these points, I would like to know which one of these has the shortest distance to all the other points. So here's the SQL that does that. We can talk about how we're going to actually calculate it. So let's copy this, and we'll put it back into the DB administrator. So conceptually, what's happening is for every point, I'm determining what's the distance to every other point. So A to A is obviously 0, but A to B is 2.59, A to C is 1.93. When I do that for every one of the points, I've created this symmetrical matrix, right? We've got a diagonal matrix, zeros along the diagonal, but then I can add up the total distance. So this is the total distance of A to every other point, the total distance of B to every other point. Then the important thing would be to then find the one which has the lowest amount, and that's point D here, which is 9.97. So let's look at our query. I'm going to collect the distance between A and B. Now, what's A and B? Well, it's the same table, points. but I'm saying points as A, points as B. So I'm pretending as though there are two different tables, one called A and one called B, and they're identical. Now I want to compare the distances where the name in the first table is not equal to the name in the second table, right? It makes no sense to calculate from point A to point A. That's going to be 0. So I'm going to get the distance, and I'm going to sum up those distances. Now that's not the distance from all points to all points, because I'm also collecting the name of the point table. So the A, B, C, D, and E, and I'm grouping it by it. So that's going to sum up the distance of A to all the other points. I'm going to also order by the distance, which is going to be my lowest and my highest, and then I'm going to say limit 1. But let's not do that right now. Let's first execute this. And that's all of our distance. So here's that 9.96, C is 11.15, and it's a little hard to see that right here, but those are the same numbers there. But I'm going to order it by distance, and then I say limit 1. And I execute that, and now I have the distance. So this tells me that D is the centermost feature. Well, the next thing we want to look at is the mean center. So this is another way of measuring data. Before we looked at the centermost feature, now I want to find within this whole space, where is the center of mass? Now one thing we can do, if I have the X and Y values, which I don't, as columns, we can use the average X and the average Y to get our averages. But what I'm going to do instead is use the geometry feature. So let's look at this. And here I'm going to say st underscore x of, and it's not geometry, it's geom. There we go. As x, the average y coordinate, the st underscore y gets me the y coordinate of the geometry. I get the averages, and then I can run that. And that's my average x and y coordinate. Another thing we can do is compute the weighted mean center. So I'm going to select that query. And in this case, let's first say select star from points. And we'll run that. All right, so I've got the name and I've got the frequency count. So B has the most frequencies. Obviously, we're going to get a little closer to B for our mean center when we compare the weights. Before, the other query did not look at the weights. Instead, what it looked at was just the locations themselves. And I'm going to make that not F, but FREQ and FREQ. So what we're doing is we're summing up the X coordinate times the frequency and dividing it by the total sum of the frequencies and the sum of the Y coordinate times the frequency. So we can run that. And when we execute this, I now have, and I could have called that probably as X and then as Y. That way we get better column names. There we go. So that's my weighted mean center. The long and the short of it is, if you can find a formula, you can recreate it inside of SQL. Let's look at another one, the nearest neighbor analysis. We often like to do that to find out which neighbor is near another neighbor. And then the average nearest neighbor. So I'm going to do this for our parks data. And let's take our parks. Excuse me, our fire stations, not our parks. And let's open up QGIS. So here's our fire stations. Let's zoom to the fire stations. Okay, so these are the fire stations, and what I'm really trying to calculate now is for each fire station, who's its nearest neighbor. This fire station here is probably nearest to that one. This fire station is nearest to that one. This fire station is nearest to that one. What's the average distance for fire stations is really what we're looking for. So the first thing I'm going to do is let's find the distance between each fire station and each other fire station. Look, we did that same trick again, right? Fire stations as A, fire stations as B. You don't have to put the as in there, so we'll leave that one off on that one, so just to show that we can do it. And also, I don't want to look at the fire stations that are the same one. so where A and B are not equal to one another. Then I want to order it by the name and the distance. So this is going to give me, well, let's just show you. Well, let's run it. And that gives me, for each station, it's going to give me the distance to every other station. So Brooklandale Fire Station to Brooklandale Volunteer Fire Station, Brooklandale Fire Station to Slaterville Station, Brooklandale Fire Station to Varna. So this is giving me all the distances from every fire station to every other fire station. There's now 650 rows, right? So there's a lot, because again, we're looking at Lansing Station 4 to every other station. So that gets us part of the. And I'm going to go through this example this way because this is how I often solve problems. I bite them off one chunk at a time. So if I've got this, then the question is, what do I really need to do? Well, I really need, since they're ordered, okay, in ascending order, lowest to highest, that means Brooklandale Fire Station's nearest neighbor is Brooklandale Volunteer Fire Station, which is 1,300 meters away. And then I can scroll down through and get past Cayuga Heights Fire Station. That's closest to Lansing Fire Station, okay, by about 300 meters. So really what I want to do is grab each of the lowest values for every fire station. I kind of want to pop those off the top. Well, we've done this before using the group by statement. So I want to get the minimum distance and the name, and I want to group it by the name of the first fire station. So again, Brooklandale Fire Station, then Cayuga Heights, then Danby. So I a lot of times do something like this. Select star from, and let's just wrap this up as T1, table 1. Okay, same value, but now what I want to do is get a name. So the place name for the fire station I called a name, and I want to get the min dist because I've calculated the dist, and then I want to come down here and say group by a name. So this is again an aggregate clause, and for every fire station I want the minimum distance, and there it is. So now I know the minimum distance from Brooklandale to its nearest neighbor, and it turns out Brooklandale Fire Station, Brooklandale Volunteer Fire Company are both nearest neighbors to one another. That's why it's the same distance. Cayuga Heights, its nearest neighbor is 2,400 meters away. So we're not quite there yet because I want the average nearest neighbor distance. And we come back in here and I've just wrapped this one in parentheses and selected the average. So again, I can do something like this. Select star from, close that guy up, call it as T2. Because we have to give it an alias name. Okay, same table as before, but instead of the star, now I can say AVG dist. I'll make that as dist, so I need to calculate something. So this is getting me the minimum distance from each station to its closest station. This is now getting me the averages. That's it. So this is the average nearest neighbor distance for fire stations in Tompkins County. So you can sort of see that you don't really need a special function to do that. We can just do it in SQL.